Okay, this rule is going to be the quotient rule. So hopefully you remember that quotient means to divide. So on your formula chart, it looks a little bit different, but basically is the same thing. So our quotient rule is when we divide, we actually end up subtracting the exponent. So yesterday we learned when we multiply, we add exponents. So when we divide, we subtract exponents. So basically the opposite. So if I were rewriting this right here, x to the a divided by x to the b, again, notice they have the same base. They both have an x. If this was an x and this was a y, you could not do this. But because they both have the same base, we actually just subtract a and b. So I would rewrite this as x to the a minus b. So let's look at some examples. So it says find each quotient. So we have x to the fifth divided by x cubed. They have the same base. So again, all we do is subtract these. I'm going to write this in expanded form and show you why subtraction is what works. So x to the fifth could be rewritten as x times x times x times x times x. 5 x's, right? X times itself 5 times. Divided by x cubed, which is x times x times x. What we know is that anything divided by itself is 1, right? So x divided by x basically is 1, and so they basically just cancel each other out. I'm going to kind of mark it like this so I know that that's a 1. This would be a 1. This would be a 1. Well, 1 times 1 times 1 is still 1. So essentially they just cancel each other out. What we're left with are these two right here in the numerator. So x times x is the same thing as x squared. If all I had done was do 5 minus 3, I get x squared. So same exact thing there. Okay. All right, so let's look at the next example. I have k to the 12 divided by k squared. So again, if I were going to write this out, I would write 12 k's being multiplied times each other, and then this one would be 2. 2 of those would cancel, and I'd be left with 10 on top, which is the same thing as 12 minus 2. So I'm going to rewrite this one like this. This is k to the 12 minus 2, which is the same thing as k to the 10. And that's it. Number 3, this one's a little bit tricky. So I'm going to write this one in expanded form. It's a little bit shorter. So I have m cubed divided by m cubed. And some of you maybe already know what this is, but m cubed in the numerator would be m times m times m divided by m cubed, which is m times m times n. Well, we just said on the first example that anything divided by itself is 1. So this is 1, this is 1, this is 1. So 1 times 1 times 1 is 1. A very common mistake is that students do 3 minus 3 and they get 0, so they put 0 as the answer. We haven't actually learned this yet, but anything to the 0 power is actually 1. So you could use your calculator, and I'll actually show you this in my calculator here. So if I go in my calculator, I can actually type any number in and raise it to the 0 power, and it will tell me that it's 1. So if I do, for example, 5 to the 0 is 1. If I do 1, 2, 3, 123 to the 0 power, that's 1. So any number that you type into the 0 power is going to be 1. The same applies for variables. So any variable also raised to the 0 power is 1. Okay. So on the next set of examples, now we have 2 variables. So just like yesterday when we were multiplying, we put A's with A's, B's with B's. So I'm not just subtracting all of these. I'm subtracting the A's from, or these A's from these A's, and these B's from these B's. So if I were writing this out kind of mathematically, this is A to the 6 minus 2, because I have 6 here on top in the numerator and 2 in the denominator. So I would do 6 minus 2. And then the b's are 4 minus 3. And then if I simplify that, we get a to the 4th, and we get b to the 1. Remember, I don't have to write this one. So an example of writing this without that would be a to the 4th b. And that would be your final answer. All right, so number 5. Again, we're doing p's with p's, q's with q's. So I have p to the 7 divided by p to the 4. So I just subtract these. So 7 minus 4 would be p cubed, or p to the 3. Okay. And then q, I have 16 here and 12 here. So 16 minus 12 would be 4. So q to the 4th. And then the last example in this section, now we just have 3 variables. So same thing, x's, we're going to subtract x from x, y from y, z from z. So I have x to the 20 divided by x to the 5. So again, very common for students to actually divide these. We don't divide, we subtract. So 20 minus 5 would be 15, so x to the 15. Here we have y to the 9 divided by y to the 9, which is going to give us what this one did, right? 9 minus 9 is 0. So I'm going to go ahead and write that, and then I'll show you how we want to simplify that. And then we have z squared divided by z. This is z to the 1. So 2 minus 1 leaves us with z to the 1. So that would be a correct answer. However, we don't want to leave it like that because we don't write anything to the 0 power like this, right? M to the 0 was 1, so y to the 0 is also 1. So we would actually write this as a 1. So we're multiplying all of these. Z to the 1 is the same thing as just z, and x to the 15 is still x to the 15. So x to the 15 times 1 times, this is a z, not a 2, times 1 times z, well, 1 doesn't change the answer, so we actually would just take that out. So our final answer would just be x to the 15 z. And that's it. So basically all of our y's canceled out. They just all went away because when we subtract those, we get 0, and anything to 0 is 1. Okay, so let's look at some examples then with coefficients. So just like all the other rules, you actually do what the problem says with the coefficients. If I didn't even have this x to the 4th and x cubed, so imagine that's not there, I just have 6 divided by 2, and no one would question that, but because now we have variables, we start not knowing really what to do. So you divide the coefficients and simplify the variables with the quotient rule. So exactly like we've been doing. So 6 divided by 2 is 3. And then x to the 4 divided by x cubed, we subtract these. So 4 minus 3 is x to the 1. Again, we don't normally write that, so that would be just 3x. Number 8, we have 14 divided by 7. So 14 divided by 7 is 2. Then we have r squared divided by r. Again, this is 1. So we subtract those. 2 minus 1 is 1. So r to the 1. S squared divided by s would also be s to the 1. So again, if I'm writing that technically correct, it would be 2rs. Number 9, we have negative 36 divided by 4. So that is a negative 9. And then we have c squared divided by c squared. So we've seen 2 examples like this. Basically, those are just going to cancel each other out. If you wanted to write c to the 0, you could, but it would be perfectly fine to also just not put that at all. We know that's just going to cancel each other out. And then we have d to the 5th divided by d cubed. So we subtract these. So 5 minus 3 is going to be d squared. So our final answer is negative 9d squared. All right, so I'm going to let you try the next 3, but then I want to go ahead and look at some on starting with number 13. So now number 13, we have the power to a power rule. So notice we have one variable, 2 exponents. So this is the power to a power rule, and then we're going to divide. So again, in PEMDAS, exponent comes before divide. So we do this part first, the numerator, where we have a power to a power, and then we're going to divide. So we want to first simplify the numerator. So remember, we raise the coefficient to the power. So 3 squared is 9. 3 times 3 is 9. X to the 5th squared. We have one variable, 2 exponents. So we multiply these two. So 5 times 2 is going to be 10. So that's going to be x to the 10. Now we've simplified that, so we can divide by 27x cubed. right? So now we do 9 divided by 27. It's very common for students to say that this is 3. It is not. If the denominator is bigger than the numerator, it's going to be a fraction. So 9 divided by 27 is actually 1/3. If you use your calculator, you would see that. So 9 divided by 27 is 1/3. Then we have x to the 10 divided by x cubed. When we divide, we subtract these. So 10 minus 3 would be x to the 7. All right, so I just want to show you this is a good way to write this. Another way would just be x to the 7 divided by 3. There's like an imaginary one here. Really important, though, that you don't put this x to the 7 in the denominator. So if I wrote it, I'm going to erase it after I'm done because this is not correct. If I wrote it 1 divided by 3 and I put x to the 7, try this again. So 1 divided by 3 and I put x to the 7 in the denominator, this would not be correct because this x to the 7 actually either needs to go to the side or in the numerator. It is not in the denominator, and in a couple of days we'll see why. So please don't do that. All right, let's do another one like that. So let's go to number 15. So number 15, this time our parentheses with our extra exponent is in the denominator. So the numerator, we're not going to do anything with that just yet. So I'm just going to rewrite my numerator. So we have 12w to the 9 v to the 4th divided by. All right, now we're going to deal with this. So we're going to do 4 squared is 16. Then we have w to the 1 squared, 1 times 2. We multiply when we have an exponent, right? There's an imaginary 1 exponent there. 1 here also. We multiply those. So 1 times 2 is 2. So w is going to be squared. V is also going to be squared. All right, so now we can simplify. We have 12 divided by 16. Well, that's not going to be even, so we need to figure out what goes into both of those or use our calculator. What I know is 4 goes into both 12 and 16. So 4 will go into 12 3 times, 4 will go into 16 4 times. So 3/4. Or use your calculator. W to the 9 divided by w squared. Now we're subtracting these. So 9 minus 2 is 7, w to the 7. V to the 4th divided by v squared is going to be v squared as well. So you could write it like this. Another appropriate way of writing it would just be 3/4 like this, and then w to the 7 v squared. Again, what you don't want to do is put this or this in the denominator. It either needs to be out to the side or in the numerator. All right, I'm going to do one more. We'll do 16. So notice on 16 now we have parentheses with an exponent, parentheses with an exponent, and both the numerator and denominator. So now we have to simplify both. So I'm going to start with the numerator. So we're going to do 2 to the 4th, which is 2 times 2 times 2 times 2. So either use your calculator, or if you know 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 to the 4th is going to be 16. All right, then we have c to the 1 to the 4th. So this is a variable with an exponent with its own exponent. So 1 times 4 is 4.
Students, teachers, we are resetting our panel, so please disregard any alarm sound. You might hear 1 or 2 beeps, and then it should be off. So again, this is a test. You can disregard any fire alarm sound. Thank you.
All right, so sorry about that. There's an announcement. They might be resetting the fire alarm, so if the fire alarm goes off, I'll just pause for a minute. All right, and then we have d to the 4th to the 4th. So again, we have one variable, 2 exponents, so 4 times 4 is going to be 16. All right, then the denominator, same process. We have 2 squared, so 2 squared is 4, because 2 times 2 is 4. Then we have c squared squared. Again, we multiply these, so 2 times 2 is 4, so c to the 4th. All right, and then we have d cubed squared. So again, we have one variable, 2 exponents, so we multiply. 3 times 2 is 6, so d to the 6. All right, and now we simplify using the quotient rule. So we have 16 divided by 4 is 4. Then c to the 4th divided by c to the 4th. These are the exact same thing, so those will cancel out. Essentially, they're going to give us 1. It's actually going to be c to the 0, which we know equals 1. So we don't even have to write it because multiplying by 1 doesn't change the value of anything. Then we have d to the 16 divided by d to the 6. So we subtract. 16 minus 6 is going to be d to the 10. So 4d to the 10.